Alaikum. Today I am going to tell you about something what are point of inflections, where its uses and different scenarios where it used and where it come from and what are the logic behind the point of inflection. So starting with the definition, an inflection point is a point on the graph of a function at which the concavity changes. For concavity changes up to this. Now, what does it means? It means that if the graph is concave upward, so it will turn down as concave downward, and if it is downward, it will come as concave upward. This means the concavity changes. And furthermore, points of inflection can occur where the second derivative of a function becomes zero. We can write it as second derivative of a function is zero. And the third thing, we can also say that the point of inflection is a point on a smooth plane curve at which the curvature changes its sign. For example, if it is positive, then positive sign, it will change its sign to negative, and if it is negative sign, it will change its sign to positive. Now come on, let's discuss these points one by one. Suppose we have a cubic function that is x cube plus 4x square plus 7x. So we know that the graph of the cubic function looks like this one. First the concave downward, then this one, then comes down, and then it will concave upward. So here we are 2 points, that is, one is maximum and this one is minimum. The region below the maximum point is known as concave downward, and the region above the minimum point is called the concave upward region. We can see that this is concave downward region and this is concave upward region. So where the point of inflection lies in this graph, for the first part of the definition, that the point where the concavity changes. So we know that this is the graph and it's concave downward. At this point, at this particular point, the graph changes its concavity. Now the graph is moving like this and it is concave upward. So this point is called point of inflection. Now if we take point of inflection, now if we take the derivative of this function, that is x cube plus 4x square plus 7x, we will get 3x square plus 8x plus 7. This is the derivative of this function. So come on to next point. Is a point like this one. So we come on to the graph. We conclude that now that after derivative, the function equation becomes a quadratic equation, and we know that the function graph of the quadratic equation is a parabola. So here is the parabola. The other definition of the concavity point of inflection is that if it is increasing, then it will point of inflection is a point where the decreasing will change into increasing, and from where increasing will change into decreasing. So the graph is decreasing like this, and at this particular point, the graph is static, and from there it start again increasing. So this point is called point of inflection. Now if we again take the derivative of the same function, that is a quadratic function, like 3x square plus 8x plus 7, we will get 6x plus 8. Now it becomes a linear equation. We also know that the graph of the linear equation is a straight line. So if we plot a graph for this second derivative, we will get a straight line. And the third part of the definition states that if the third part of the definition states thus flexion is a point on the smooth curve at which the curvature changes sign. So here we can clearly see that the graph is from negative to positive. The first part is negative part, and after this static point, the graph changes its sign, that is, it will now become a positive part. So the point where the negative and positive signs intersect or interchange is known as point of inflection. So this is basically the what are the points of inflection points. What are the different conditions we have discussed? The cubic form, then the quadratic, and then the linear. So this is up to my side. How will this will be better? Thank you very much, sir. Assalamu alaikum.
Assalamu alaikum, sir. My name is Mahad, and the question assigned to me was point of inflection. So let's start. So what actually point of inflection is? Point of inflection is the point at which the whole transition occurs, at which the whole scenario changes. So if we look at the graph number 1, we can see that the slope increases, but suddenly it becomes constant, like the rate becomes constant. So here in graph number 1, the point of inflection is this, right here at this spot. This is the spot where the whole transition occurs. So if we have a look at the graph number 2, we can see a concave like shape, a concave like graph. So first the slope is increasing, and then suddenly at a certain point it becomes constant, and then suddenly it becomes it it starts to decline and eventually becomes zero. So in this graph, the point of inflection is this spot where the whole transition occurs, where the whole scenario changes of the story. So in the topic of point of inflection, we will usually discuss about concaves. So point of inflection is also known as concave transitions, concavity transitions. It is also known as concave transitions. So this shape right here is known as downward concave. Downward concave. And if we turn the shape like this becomes an upward concave. So majorly we will discuss about concaves. That's why point of inflection is also known as concavity transitions. So in graph number 3, we can see that there are two concaves. Here one is downward concave, and the other is upward concave. So in this scenario, which one is the point of inflection? So where the whole transition occurs, where the downward concave shifts to the upward concave, is known as the point of inflection. So in this case, the point of inflection is right here. This is the point of inflection. So majorly we will discuss like these examples, graph number 2 and graph number 3. But another scenario is the graph number 4, where there is a straight line and the transition occurs from negative value to positive value. So the spot where the spot where the line changes its value from negative to positive is the point of inflection. So this here is the point of inflection. Point of inflection. So I hope that you would be clear about what actually point of inflection is. And point of inflection is also known as concavity transitions. So we will discuss an example of example where we will have to find the point of inflection. So in this example, we have to find the point of inflection of this equation. So what actually gives us the value of point of inflection? The second order derivative always gives us the point of inflection. I mean by this that the second order derivative will give us the point of inflection of the equation. So let's find the point of inflection of this equation. Solution. First we will find the first order derivative, which will be y over dx, dy by dx, and which will become 6x square plus 12x minus 3, and as 9 is constant, so it will become 0. So this is the first order derivative of the following, the up mentioned 12x, sorry, my bad, and 3. This is the first order derivative of this equation. So now we will find the second order derivative, and it will become 12x plus 12, and as 3 is constant, so it will become 0. So this is the second order derivative of this equation. So how we will find the point of inflection of the equation of line this? We will put it to the critical value, which is 0. So 0 is equals to 12x plus 12, and now it will become 12x is equals to minus 12, and x is equals to minus 1. So this is the point of inflection of this equation. So that's the whole topic, and I hope you would get the point of inflection. Thank you.